Over the last few decades, airplanes have certainly revolutionized the way we travel. But have you ever thought of how it flies? How does it navigate? We will get answers to these questions from this video in a simple yet scientific way. We will also explore how the flight is controlled in a real-time manner. First, let's look at some history. Many crazy flying machine designs were tested in the 19th century because of mankind's quest to fly. Finally, one attempt succeeded. Yes, you are right. It was the flight of the Wright brothers. Their aircraft was a success thanks to an interesting physics phenomenon: the airfoil technology. The wing of the aircraft was able to produce lift force in an ingenious way. The wings had a curved shape. This shape pushes the gushing air downward, as shown. Newton's third law of motion works here. If the wing pushes the air downward, the air should also push the wing in the opposite direction with equal magnitude. This eventually results in a lift force, and the aircraft will be able to fly off the ground. Even today, aeroplanes make use of the same airfoil technology to fly, but with a highly aerodynamically optimized airfoil shape. Thrust force makes an aeroplane move forward. To produce this thrust, a turbofan engine is used in modern civil aviation aircraft. The reaction force of the high-velocity exit jet gives the turbofan engine thrust force. To produce this high-velocity jet, the incoming air is passed through a compressor, combustion chamber, and turbine stages. The engine also drives the thrust force from the fan's reactions, thus, the turbofan engines produce a great deal of thrust and make the aeroplane move forward. As discussed earlier, when the aeroplane moves forward, the relatively flowing air over the wing will produce a lift force on the wings. Just pause for a moment here and have a closer look at the wing. You can note that the wing of a modern aircraft is a collection of different parts. During takeoff, the flaps and slats are extended downward, as shown. This increases the wing area and curvature of the airfoil. As the curvature increases, air will be deflected more. Thus, a greater lift force can be derived even at low airplane speeds. As the airplane speed increases, the lift force rises. Finally, when the lift is greater than the gravitational force, the plane takes off. During a normal flight, the flaps and slats are put in their original positions. It is interesting to note that different forces acting on the airplane balance each other exactly during a normal flight. Now, let's get into the core of flight navigation. You can navigate the airplane the way you want with the help of 3 different wing attachments. Aileron, elevator, and rudder. Pilots use them alone or together, depending on the situation. Assume you want to descend the airplane. You can just lower the elevator. This will deflect the flow as shown and produce a lift. The lift force will create a moment that will make the nose of the plane go down. If you want to climb up, just do the reverse. Now, let's assume the airplane has to change its path. You must have an obvious answer in mind. Just turn the rudder. Of course, turning the rudder will produce a lift force and make the airplane turn as shown. But such a sudden change in flight direction may cause passenger discomfort. The professional way is through the use of ailerons. Just make one aileron go up and the other down. This will cause a difference in the lift forces, and the airplane will roll. Now observe what happens if the airplane still goes up. It is clear that the airplane has changed its path. Unlike the previous method, the airplane orientation has not changed here. All these movements of flaps and other devices are controlled from the cockpit using a fly-by-wire system. In FBW systems, the controller computer governs the exact movement of actuators for smooth operation. You can see the different controllers pilots use to navigate the airplane. Fuel required for the airplane is stored in the large tanks of the wing. During landing, it is required to increase the drag. For this purpose, flaps and slats are activated again, because they have drag racing capability too. A wing attachment called the spoiler is also activated to increase the drag further and reduce the lift. An interesting mechanism is used for lowering the flaps. The mechanism will rotate as well as displace the flaps. We hope you enjoyed the flight journey by exploring the science behind airplane operation. Thank you.